the V reference divided by 2 power 8 is equal to V reference plus minus V reference minus divided by 256. That is digital data is equal to V in minus 1 divided by Q step of 10. This is the decimal value. Here also we are initialize the ports 8255 at the port A as a input, port B, port C, and control word registers. So this is the interfacing of ADC with 8085 using 8255 programmable peripheral interface. So this is a program, then control word format for getting the input port. So here CWR format for initialize the port A as a input port, port B and port C as a output port. So we are giving the input. If I send the output to the 98 bits, it will produce the port A as a input, port B and port C as a output. Same as data required for channel selection like that, we are giving the input. Next program for ADC for analog to digital converter. Okay, this is the successive approximation type concept. Okay, so that is successive approximation value will produce some digital signals. So that is convert to the analog, compare with the given analog input. Then if it is 0 means, okay, if the both the values are same means comparative output will be 0. So the successive approximation previous value will be lags. If 1 means it will change the value, then compare. Okay, like that. So this is the ADC. So ADC mainly for getting the data from sensor, then convert the digital signal and given to the processor. Mainly used in there is a ADC concept. Then DAC. So this is the reverse process of ADC, that is digital signals. That is ones and zeros are converted into the voltage. Okay, if you are giving 1011 to the input means it will produce some voltage with the reference voltage. For example, if you are giving 1011 means it will produce some 1.5 volt. Okay, that is digital to analog converter. Here also we have two types of DAC. One is weighted resistor digital to analog converter. Another one is 2R weighted resistor DAC. Okay, first one is weighted resistor network means, so for every bit they are using the one input. For example, if you are using D0, D1, D2 means they are using the different concept, that is 2 power 1, 2 power 2, 2 power 3, like that it will increasing. Okay. Okay. So if you are using 8-bit means up to you have to use 2 power 8 register. So for this purpose the weighted resistor network will not be used, because if I increase a bit means the resistor value will be increasing. Okay, so the total current will be reduced, so output will not be given, so output will not be perfect output. So we are using the R2R only. We are using the two resistors only, that is R2R, that is R2R ladder network. Okay, only two resistors. If you are using 1 kilo ohm means 1 kilo ohm and 2 kilo ohm resistors only used in the whole circuit, with the depend on the number of values. Okay. So this is a formula for getting the output. V out is equal to V reference RF divided by RF, D2 divided by 2 power 1, D1 divided by 2 power 2, then D0 divided by 2 power 3 for 3 bit. So DS is 0808, it is a 8-bit digital to analog converter. Okay, there is a specifications, electrical specifications of DSC, that is fast settling time will be 150 nanosecond time for conversion of 1 bit. Okay, high speed multiplying input sleeve rate, that is 8 million per microsecond. So low power consumptions. Okay, this is the IC for DSC 0808 with the 16-pin package with the power supply input selected. Okay, there is a switches. Okay, switches means input. If I give 8-bit means it will produce the some output voltage. Okay, that is with the reference voltage, it will produce the some voltage. This is the concept. So this is the interfacing of DSC with the microprocessor based system. Okay, 8085, then 7473, it is a latch, then DSC, digital to analog converters IC with the processor. Okay. So this is the initialization process of connecting the DSC with the 8085 microprocessor. This is the interfacing concept. So this is the control word concept, that is D7, D0. If I am giving 80 means it will produce the some port A as a output port. Port A as a output port. Then program. Okay, then interfacing with the 8051, same concept that we are using. So in interfacing, we can use the 8085 and 8051. So main difference is in 8051. So there is one. So 8051, there is no. So 8051, there is no need of 8255 because 8051 having input output ports in inbuilt. So this is the difference between 80 and 85. Okay. Okay, this is the unit 3 end. Okay. We will see in the next class. Thank you.